We just learned cross-media approach. In this online session, we're going to learn a second model. It's called half retail location model. So when locating a retail store, such as supermarket, the objective is to maximize profit. In this case, oftentimes we need to evaluate a discrete number of alternative locations to see which one is the best in terms of which one can make the most profit. So a commonly used model is called a gravity model. We use gravity model to estimate consumer demand and consumer market share. So a half model is such a gravity model that predicts the benefit a customer would have for a particular store size and location. So basically for half retail location model, we look at two things. One is store size, the other one is travel distance to determine the market share. So one thing we need to know is for cross-media approach, we can use cross-media approach to find out the best location. And however, for half retail location model, the model does not tell us what is the best location. Instead, the model only let us evaluate a given location to see how much market share can capture. So for cross-media approach, you can use cross-media approach to identify the optimal location. However, for half retail location model, we cannot use half retail location model to identify the best location. You have to identify location first. Then we can use half retail location model to assess it, to evaluate. So here are different steps. So for half retail location model, it takes 4 different steps. The first step is to calculate attraction or how attractive each location is. So basically, when we do a half retail location model, typically we deal with multiple stores in the same region. So we look at these multiple stores to see which one is more attractive or which one can capture more market share. So in this case, we have some assumptions. So this is a basic assumption for a half retail location model. So how attractive each potential store is to customers who live in a specific area. It depends on 2 things. So the numerator is the size of that store. So basically you can see if the store size is larger, that means the store is more attractive. That means the store will capture more market share. So that is the first assumption. So it depends on store size. The second, you look at the numerator, the denominator. As TT is the travel distance. So basically, if the travel distance is longer, that means the store is less attractive. On the other hand, if the travel distance is shorter, that means the store is more attractive. That means it will capture more market share. Obviously, that makes sense. So the lambda here. So lambda is a parameter that captures sensitivity of travel distance. So typically, larger lambda implies that customers are sensitive to travel distance. Smaller lambda implies that customers are less sensitive to travel distance. So the exact value to use for lambda depends on the nature of your store. So basically look at what type of product you're selling. For example, if we look at convenience store. So for convenience stores, of course, convenience is very important. So travel distance, of course, is very important. That's why if you're looking at convenience stores, lambda, we should use larger value because people do value travel distance. It's very important consideration. On the other hand, if you're looking at furniture stores, for a lot of furniture stores, because it's expensive, so people are care less about travel distance. They are willing to drive, for example, 20 miles to get the best product they want. So this is different compared to convenience stores. So for furniture stores, you can use a smaller value for lambda because in general, customers are less sensitive to travel distance compared to convenience stores. So that is the first step to calculate attraction for each store in each area. The second step is calculate the purchasing probability. So when customers have options, let's say customers live in the same region, they have 2 or 3 stores as shopping options. So which store they want to go, how likely they're going to go each of the 3 stores. So it depends on what attraction. If one store has a larger attraction, that means for this particular customer, they're more likely to shop from the store. So this one, the second step is based on the attraction of different stores, we can calculate the purchasing probability. I give you, this is very messy formula. Later we'll see a very concrete example. We will figure out how to do it. Step 3 is to calculate customer expenditure in different areas. So basically, we look at the annual budget for product K for each customer living in a specific area and times how many customers we have in that area. This is total expenditure for customer living in the same area and times the purchasing probability from a particular store. Adding them together, we can get the total expenditure for a particular store. The last one, of course, is calculating the market share. So how much market share each store can capture. So this is a general framework. Also, it's right now you may feel it's kind of confusing because the formulas are not very straightforward. It's very messy. But later, when we see the actual example, you'll get that sense how to perform the calculation or analysis. To summarize, a Hub model includes 4 steps. Step 1 is to calculate travel distance from each customer area to each store. Step 2, to calculate the attraction of each store in each area. So travel distance, then attraction. Step 3, calculate the purchasing probability for each store, for each customer area in each store. And the last one is calculate the customer expenditure for each store and the corresponding market share. So there are 4 different steps. Now let's look at a particular example. This example is from the textbook. It's example 8.2 on textbook page 230. So look at this map. These red dots, these 4 represents 4 customer areas. You can view 4 cities or 4 communities. So I have 4 different customer areas. And the number for each area, look at the number inside the parentheses. That shows the total customer expenditure. That's forecasted customer expenditure in each area. So for example, if you look at customer area 1, each month, customers who live in area 1 are going to spend about $7,000 in retail shopping. Similarly, for those who live in customer area 2, in total, they are going to spend about $1,000 in retail shopping. And then for customer area 3, they're going to spend about $3,000. And the customer area 4, altogether, they're going to spend about $5,000. So the numbers inside the parentheses shows the total expenditure for customers living in a specific area. So currently, look at the middle 2 dots. The blue one is a location for the current store, or we call existing store. So right now we have 1 store only. So this is the only option, okay? For everybody who live in these 4 different areas, currently there's only 1 retail store, which is the existing store. The store size is 1. It's pretty small, so size is 1. So now there's no option. So store 1 will capture 100% market share currently. So now we are trying to build another store we call proposed store. So we try to compete with existing store. So this is the location we plan to build. So the green dot shows the potential location for the proposed new store. And we're going to make it larger. So store size is 2 compared to the old store, the existing store. Store size is only 1. So we're proposing to build a brand new store in this location with a store size of 2. And we want to figure out, currently, the existing store is capturing 100% market share. What we want to do, we want to analyze if we were to build a proposed store in this particular area, only this particular area, how much market share does the new store capture? And then how much market share does the existing store capture? So this is what we want to do. So given 2 stores, the existing store and plus the proposed new store, we look at these 2 stores and try to analyze how much market share each store will capture for this whole region. So that is about Hub retail location model. So let's work on this. So step one. So what is step one? Step one is to calculate travel distance. So here, when we calculate travel distance, we want to calculate travel distance from each custom area to each store. So I have 2 stores, 4 custom areas. So we want to calculate travel distance by metropolitan distance. So look at here. First thing I want to do, I want to calculate look at the map. What is the travel distance from custom area 1 to the proposed store? So for those who live in custom area 1, how long it takes to travel to the proposed store? So this is custom area 1, and this is the proposed store. So what is the travel distance? We measure by metropolitan distance. So if you look at custom area 1 and go into proposed store, so the distance is 1 and then 2. So 2 units, the travel distance is 2 units if you look at the map. So from 1 to the proposed store, so 1 and a 2. So that's why it's 2, travel distance is 2. So what about for those who live in custom area 2? For those who live in custom area 2, what is the travel distance to the proposed store? So from here to here, what is the travel distance? Again, we look at metropolitan distance. So it'd be 1, 2, 1, 2. So travel distance is 2. What about from custom area 3 to the proposed store? So from here to here. So what is the travel distance? So if you go from here, it will be 1, 2, 3. So travel distance is 3. So what about custom area 4 to the proposed store? So from 4 is here, the proposed store. The travel distance will be 1, 2. So it's 2. Now let's look at travel distance from each custom area to the existing store. So the blue one is the existing store. So first of all, look at what is travel distance from custom area 1 to the existing store. So 1 to existing store. So from here to here. So it's just 1. So this is a 1. What about custom area 2 to the existing store? So it'll be 1 as well. This is travel distance. What about custom area 3 to the existing store? So 3 is right here. So how long it takes to go to the existing store? So it'll be 1, 2, 3, and a 4. So it's 4 units. So what about customer area 4 to the existing store? So 4 is right here. So how long it takes? So it'll be 1, 2, 3. So it's 3 units. So by doing this, we're basically looking at the travel distance by measuring travel distance by metropolitan distance. Now we have a table, okay, a 2x8, a 2x4, because we have 4 customer area, 2 potential stores. So this is the step 1, calculate travel distance. How to do it? Basically, just look at the map, measure it. Now we already have the results. This is step 1, the results from step 1. Now let's do step 2. Step 2 is about calculate attraction. Okay, attraction of each store in each custom area. So first of all, let's look at the proposed store. So how attractive is the proposed store for those who live in custom area 1? Okay, how attractive is the proposed store for those who live in custom area 1? So if you recall how we define attraction, we define attraction by 2 things. One is the store size, that's the numerator. And the second one is about the travel distance, which is denominator. But we also have the lambda. Lambda is measures how sensitive our customer to the travel distance. So you look at the first one. We want to see how attractive is the proposed store to those who live in custom area 1. So this is how we calculate attraction. So the numerator is the store size. So we know for the proposed store, the store size is 2, so that's why it's 2. Okay, that's the store size for the proposed store. Denominator, we have travel distance, which is 2. 2 is from here, which is travel distance from custom area 1 to the proposed store, which is 2. And we do the power function. This is lambda. So lambda here is 2. For this particular application, the value for lambda is 2. That's why it's 2 squared. and you do the math, you get 0.5. Similarly, we can also calculate the attraction for those who live in customer area 2. So how do we calculate attraction? The numerator is that store size, the proposed store size, which is 2. The denominator, travel distance, which is 2 as well, 2. And we do the squared because lambda is equal to 2. For this particular application, lambda is always 2. For different applications, lambda value can be different. Now let's look at the attraction for the proposed store in custom area 3. So you can imagine the numerator is the same, 2, store size. A denominator, now the travel distance becomes 3. We can also do custom area 4. The numerator is 2, the denominator is 2, 2 power function. So now let's do the same, apply same procedure. We want to calculate attraction for the existing store. So remember, for the existing store, the store size is not 2, it's 1. So look at how attractive is the existing store to those who live in customer area 1. So the numerator will be 1 because store size is 1 for existing store. Travel distance is 1, it's 1. We can also do custom area 2. Numerator is 1, denominator is travel distance, which is 1. For custom area 3, numerator is 1, and denominator is 4. Travel distance is 4. And for custom area 4, numerator is 1, denominator is 3. So that's how we calculate attraction for each store in each area. So we get A numbers. Next, we need to do the sum of attraction for each custom area. So how do we get 1.5? It's 0.5 plus 1.0. And we also want to do for custom area 2. 0.5 plus 1 is 1.5. We need to do for custom area 3 and 4 as well. So how do we get 0.285? Basically to 0.222 plus 0.063. How do we get 0.611? We do 0.5 plus 0.111. So we need to do a sum for each column. So that completes step 2. Now let's move to step 3. Calculate purchasing probability. So we want to see for those who live in customer area 1, for example, how likely they have 2 options to shop. They either go to the proposed store or they can go to the existing store. So now in step 3, we want to calculate how likely for those who live in area 1 will go to the proposed store and how likely they will go to the existing store. They only have 2 options. They either go to proposed or go to existing. So how likely? What's the likelihood, the probability? So if you think about step 2, in step 2, we calculate the attraction of the 2 stores. So if the value of attraction is larger, that means this store is more attractive for the people who live in that area. So the larger attraction means larger purchasing probability. So for example, if you look at those who live in customer area 1, they have 2 options to shop. One is the proposed store, which has the attraction 0.5. The other one is the existing store, which has attraction 1.0. You can see 1.0 is larger than 0.5. That means for those who live in customer area 1, they're more likely to shop from the existing store and less likely to shop from the proposed store. Now the question is, what is the precise probability? So what we can do, we'll do proportional allocation based on attraction. So for example, how likely customers who live in customer area 1 will shop from proposed store will be 0.5, which is the attraction for the proposed store, divided by 1.5, which is a total attraction, So you will get 0.333. Similarly, we can also calculate the purchasing probability for those who live in customer area 1 from the existing store. So again, we'll use 1. 1 is attraction for the existing store divided by 1.5, which is total attraction, 1.5. Similarly, we can apply the same procedure to calculate the purchasing probability for those who live in customer area 2. Oh, this is the one. Of course, if you add these two numbers, it will be 100%. You have to be 100% because these are the only two options available. Now let's do customer area 2. For customer who live in area 2, how likely they will shop from the proposed store will be 0.5, which is the attraction for the proposed store, divided by 1.5, which is total attraction. So we get 0.333. So how likely they are going to shop from the existing store? So it will be 1, which is attraction for the existing store, divided by 1.5, which is total attraction. So you get 0.667, and total is 1. What about customer area 3? How likely they are going to shop from proposed store? We're going to use 0.222, which is that attraction for the proposed store, divided by 0.285, which is that total attraction. So we get 0.779. We can also calculate the purchasing probability from the existing store, so which is 0.063. This is that attraction for the existing store divided by 0.285, which is total attraction. Total is 1 again. So for customer area 4, we'll do the same thing. 0.5 attraction for the proposed store divided by total attraction, 0.611. And then for the existing store, 0.111 attraction divided by total attraction. The total purchasing probability, if you add the two numbers, will be 1 as well. So this completes step 3. So in step 3, we basically calculate the purchasing probability for those who live in each area from one of the two stores. How do we do it? Basically, we proportionally allocate based on the attraction of all the stores. Now let's move to the last step. Step 4 is about calculate market share. Okay. So this is talking about the total market share, not the market share in each customer area. We're talking about overall aggregate total market share. So we're going to take a look at 4 different customer areas. We'll look at 2 different stores. We'll look at total. So these 4 numbers shows the total expenditure, customer expenditure in each area. So this is given information. If you go back to the previous slide, you can see this is given information. For example, the monthly expenditure for those who live in customer area 1 is $7,000. And for those who live in customer area 2, $1,000. Customer area 3, $3,000. Customer area 4 is $5,000. So these 4 numbers represent total spending of customers in each area. So basically, for those who live in customer area 1, they are going to spend $7,000 per month on retail shopping. Now the question is, if you look at these $7,000, how much of these $7,000 will be spent in the proposed store, and how much of this $7,000 will be spent in the existing store? So how do we do the calculation? It's based on the purchasing probability. Okay, we can go back and look at purchasing probability. So first of all, we have $16,000. We want to calculate how much total spending for everybody together. So these 4 numbers represent the spending from each area. $16,000 is simply a sum of these 4 numbers that represent the total spending for everybody combined, all 4 areas. Now let's look at this, $7,000. How much of these $7,000 will go to the proposed store, and how much of these will go to the existing stores? So for the proposed store, total $7,000, you can look at the purchasing probability, which is 0.333. So 0.333 times 0.333, which is $2,331, will be spent in the proposed store. Similarly, so for these $7,000, the rest is 0.667. The rest is 0.667. This much percent will be spent in the existing store, which is $4,669. So out of these $7,000, $2,331 will be spent in the proposed store, and $4,669 will be spent in the existing store. So how do we get this? Based on the purchasing probability. Similarly, we can do this for customer area 2. So in total, people will spend $1,000. So how much of these $1,000 will be spent in the proposed store? So which is 30.333. So we do 1,000 times 0.333. So you get $333 will be spent in the proposed store. And also, how much of these $1,000 will be spent in the existing store? So it'll be 1,000 times the corresponding percentage, which is 0.667. So you have $667 will be spent in the existing store. We can repeat the procedure for customer area 3 and area 4. So for customer area 3, $3,000 in total, and out of these $3,000, about 0.779% will go to that proposed store, so which is $2,337. And $3,000 total, out of these $3,000, 0.221, so 0.221 will go to the existing store, which is $663. And for the last customer area 4, we have a total of $5,000. So $5,000, 0.818 will be spent in the proposed store, which is $4,090. And then the rest, which is 0.182, will be spent in the existing store, which is $910. So this is how much money will be spent in the proposed store and existing store. So what's the total? So we look at how much money will be spent in the proposed store in each customer area. So you can see from customer area 1, about a little over $2,000 will be spent in the proposed store. From customer area 2, about a little over $300 will be spent in the proposed store. Customer area 3, $2,337. Customer area 4, $4,090. So now the question, what is the total? How many dollars will be spent in the proposed store combining all 4 areas? So we do a simply sum. So 2,331 plus 333 plus 2,337 plus 4,090. So total will be $9,091. So that's how much money in total will be spent in the proposed store. So $9,091. Similarly, we can also calculate how the total spending for the existing store by simply adding these 4 numbers together. So it'll be 4,669 plus 6,067 plus 663 plus 910, and you get $6,909. So that's how much money will be spent in the existing store. So total is $16,000. So out of these $16,000, a little over $9,000 will be spent in the proposed store, and a little less $7,000 will be spent in the existing store. So what's the total market share? So for the proposed store, the total market is $16,000, and the proposed store will capture how much of them? Will capture 9,091. So 9,091 out of 16,000, that basically represents about 56.8% market share. So that is actual market share. What about the existing store? The existing store, for the total spending of $16,000, the existing store will capture about $6,909. So it's $6,909 out of 16,000, you get about 43.2%. So that's how much market share the existing store will capture. The total, of course, is 100%. So this number plus this number is 100%. So by building in the past, without the proposed store, the existing store will capture 100% market share. But if you adding a proposed new store, then the market share will be split between the 2 stores, and the proposed store will capture about 56.8%. The existing store will only capture 43.2%. So this is about half retail location model.